Hello friends, today we'll see one of the most important part of the kinematics, especially that of curvilinear motion, and that part is normal and tangential components, or in short, it is NT components, not N only, NT components, or it is treated as path coordinates also. A very important part of curvilinear motion. And in this, what you have to remember? So when curvilinear motion is there, velocity is always tangential. Means the total velocity Vt is always V. Hence, the normal component of the velocity is always 0. Means total velocity is along the tangent to the curve. So that is why Vt is V, and hence the normal component of the velocity is 0. Tangential component of acceleration, it is V dot, or you can write it is dV by dt. It is same. And normal component of acceleration, an, it is V square by radius of curvature, rho or r. Anything big you can use. And the total acceleration will be what? A is equal to under root at square plus an square. Simply these things you have to remember, and you have to use these things wisely. You will enjoy these problems of NT component. And always minimum one example is going to be there in the exam on this part. So how to deal with these examples, that I'll explain. See the very first example on this part. It is something like this. Now read it carefully. So always in the dynamics or in the mechanics, you have to read the statement carefully. A motorist is traveling on a curved path, means curvilinear motion, of the radius of radius 762 meters. Means in this example, radius of curvature, it is 762 meters at a speed of 96 kilometers per hour. So what I'll suggest, always divide kilometer per hour by 3.6. You will get meters per second. For example, it is 96 divided by 3.6. It is going to be 26.67. 26.67 at a speed of 70, means initial speed u along this curved path is 96 kmph. That means 26.67 meter per second. This conversion is very important. And the motorist suddenly applied the brakes, causing the motor to slow down at constant rate. Means that is constant acceleration, whatever it is. So hence here we can think of using the equations of motion, knowing that after 8 seconds, means after 8 seconds t, 8, yes, the speed has been reduced to 72. Means that final speed is what? 72 kmph. 72 by 3.6, it is 20 meters per second. So this is what the given data. And what is asked? Determine the acceleration of the motor when the speed reduced to 72 kilometer. Means we have to find out the total acceleration in this example. Then see how we can solve this example. See that along the curved path, acceleration is constant. Hence, easily we can use this equation. Radius of curvature, it is mentioned. Final velocity is there. Initial velocity is there. So we can use this equation. V is equal to u plus at, because this is moving tangentially along the curve. At into t. This equation we can use. And from this, at is going to be v, that is 20 minus u, 26.67 divided by 8. This is the tangential acceleration. It is the tangential acceleration. And tangential acceleration will be what? It is going to be 0.833 meters per second square. And it is constant. This is one. The next is what? So when speed is reduced to 72, at this moment we have to get normal acceleration, an. It is going to be v square by rho, and v square is what? 72 means 20 square by 762 Then an is what? 400 divided by 762. It is equal to 0.524 meters per second square. This is the normal acceleration. It is not constant. Means at this moment we have to get A is going to be 80 square plus an square. 80 is 0.833 square plus 0.524 square. And from this we'll get A. 0.833 square plus 0.524 square is equal to 0.894. 0.894 meters per second square. And this is the answer. What is asked? Determine the acceleration of the motor when speed reduced to 72 kilometers per hour, and whatever it is asked, this is the acceleration. So it is the solution of very first example. Now we can have second example. Again, an outdoor track is 126 meter in diameter. Now be careful here. It is a diameter, means rho is 126 by 2. It is 63. The mechanics is something like this. There are so many students who may take speedily that rho is 126, its diameter. A runner increases her speed at a constant rate from 4.2 to 7.2. Means initial speed is 4.2 meter per second and final speed is how much? It is 7.2 meters per second. Over a distance of, means whatever that distance is there, yes, 28.5 meters. Correct. So it is moving along a track, and that track is, when diameter is there, it is curved. Correct. Determine the total acceleration of the runner 2 seconds after she begins to increase her speed. Means initial speed is 4.2. Now from this, first what we'll get? We'll get the constant rate, means constant acceleration over here, and that how we can get. So whenever acceleration is constant, we can use this equation. V square is equal to u square plus twice along the curved path. It is tangential acceleration. It is yes. V square 7.2 square is equal to 4.2 square plus 2 into 80 into yes 28.5. And from this directly I'll get tangential acceleration, and that how I can get 7.2 square minus 4.2 square. So whatever that answer is there, divided by 57, 2 into 28.5. So it is 0.6. 0.6 meters per second square. It's very simple. Now this acceleration remains constant, but n will not remain constant. It will go on changing. It depends on the velocity. It depends on the velocity. Then what we have to do? After 2 seconds, what will be the velocity? V is equal to u plus at into t. So u is 4.2 plus at is 0.6 into 2 means velocity is going to be 5.4 meters per second. And according to this velocity, we can get the tangential acceleration, that is v square by rho. V square is 5.4 square and rho is 63. Then hence n is how much? 5.4 square divided by 63. It is 0.463. 0.463 meters per second square. This is air. Again, in the same fashion, we can get the acceleration, total acceleration. A is going to be under root at square plus an square. It is nothing but 0.6 square plus 0.463 square. So it is square plus 0.6 square and 0.574. The answer is A is going to be 0.757 meters per second square. This is the answer. So it is the answer, whatever is required. So these problems, if we solve neatly, very simple, very fastly, within 5 minutes we can solve. Then again, one more example I'll explain. A train enters a curved horizontal section of the track at a speed of 100 kmph. Means initial speed is 100 kmph. 100 kmph. That means 100 divided by 3.6. It is 27.78. 27.78 meters per second. And slows down with constant deceleration to 50. Means V is going to be 50 kmph. 50 kmph. It is nothing but 13.89. 13.89 meters per second. In 12 seconds, T is going to be 12 seconds. An accelerometer mounted inside the train records a horizontal acceleration of 200 meters per second square. Means whatever that accelerometer is there, so that reading is going to be total acceleration, 2 meters per second square. When the train is 6 seconds into the curve, when it is 6 seconds into the curve, calculate the radius of curvature rho of the track for this instant, and with this information we have to calculate what is the rho after 8 seconds. Then see how we can solve this example. So first, with u, v and t, easily we can get at. Directly I'll write at. Actually this is v is equal to u plus at into t. At is what? V minus u by t. Means it is v is equal to u plus at equation. V is how much? 13.89 minus 27.78 divided by 12. Divided by 12. Means it is minus 1.7 157. It is 1.157 meters per second square. It is negative deceleration. It is deceleration. Correct. Then what is there? Velocity after 6 seconds. After 6 seconds. What is V? V is going to be U plus AT into T. U is 27.78 minus AT 1.157 into 6 means this is going to be the velocity after 6 seconds. .83 or 20.84 meters per second. So this is going to be useful. Now, what is given? A is given. A is going to be 2 meters per second square. 2 meters per second square. Then what will be An? An is going to be under root A square minus AT square. Actually, A square is equal to AT square plus An square. From this, you will get this equation. Or you can write A is equal to, or A square is equal to under AT square plus An square. Means An square is equal to A square minus AT square, and An means its root. So it is 2 square minus 1 point, it is the magnitude only, 157 square. So it is An. It is An. That 2 square minus 1.157 square. It is going to be 1.63. An is 1.63 meters per second square. And An means what? V square by rho. And it is 1.63. V is known, 20 point, or rho is equal to this V square by means 20.84 square divided by 1.63. So it is going to be into 20.84 square. It is 266.22. 266.22 meters. This is the radius of curvature. Or once again I'll check. Make the calculation twice. It is very important. 266.44 or 22. Let it be. So there is a minor difference. So like this, we can deal with this example. Again, one more example I'll explain. And this fourth example is what? A train starting from rest is moving along a curved track with constant acceleration and attains a speed of 60 kilometers per hour in 30 seconds. Means initial velocity of the train is 0. Final velocity is what? 60 kmph. 60 kmph. That means 60 by 3.6. 60 by 3.6. It is 16.67. 16.67 meters per second. It is 60 by 3.6. At a constant rate, means 80 we have to get in 30 seconds. Means t is 30 seconds. Then 80 is what? Means from this 80 we can get. Determine the acceleration of the train 1 minute after leaving the station. Means we have to find out total acceleration after 1 minute and take rho is equal to 800. So that rho is also given 800 meter, and when t is equal to 1 minute means 60 seconds, what is A? So this is the overall example, means whatever the data is given, it is something like this. Then from this again, what we can get? See, AT easily we can get, like earlier example, AT is now final velocity minus initial velocity by time. Final velocity is 16.67 minus 0 by 30 seconds. From this we will get AT, which is going to be constant. It is 0.555 meters per second square. Then from this what we can get? After 60 seconds, when t is equal to 60 seconds, we can get V. V is going to be U plus AT into T. U is starting from rest 0 plus 0.555 into 60, means we'll get the velocity into 60, 33.33 meters per second. This is the velocity. And now for getting the total acceleration, we are having AT, we can have AN, V square by rho, and V is 33.33 square, and rho is given, it is 800. From there we'll get AN divided by 800, 3.33 square divided by 800, 1.389 meters per second square. Means we are knowing AT, we are knowing AN also, and what we have to get? Total acceleration, which is A. A is going to be under root AT square plus AN square, and it is what? 0.555 square plus 1.389 square, and this total acceleration is it is 1.495 or 1 almost 5 meters per second square. This is the total acceleration. Or once again I'll check 0.55 square, make the calculation twice, 1.495, it's correct. So like this we can easily solve the problems on normal and tangential component by knowing only Vn is 0, Vt is V, An is V square by rho, At is dV by dt. With such simple formulas we can solve these problems. Don't miss to solve such examples. Thank you.